And the third one is sine A minus B. Is the same thing as saying sine A cos B, okay, minus sine B cos A. So you just swap the angles there. So cos A minus B is the same thing as saying cos A cos B. Then with minus it turns to plus sine A sine B. So we have a double angle relationship. So with this, we can solve for sine 2 theta or sine 2A. What is sine 2A? Sine 2A is the same thing as a sine A plus A. And sine A plus A is sine A sine cos A, okay, plus sine A cos A. So since they are the same, we have 2 sine A cos A. So if we want to solve sine 2A, using the first identity there, you can get this, or you arrive at this answer. So that means if you want to get this answer, sine 60 degrees. Sine 60 degrees is root 3 over 2. But we can solve it by using this approach. And how do we do that? We say sine 2A. Using sine 2A approach, that means sine 60 degrees is equal to sine 2 times 30. That is 2A. And that is equal to sine, so your A becomes the 30 there now. So that will give us a 2 sine 30 cos 30. Okay? 2 sine 30 cos 30. Sine 30 is half. So we have 2 times half. And cos 30 is root 3 over 2. So 2 cancel 2. The answer is root 3 over 2. So the same answer as sine 60, just exactly the same. So you can solve for others and check and see how the values also vary. So we can also solve some other problems when you want to find the value of something like sine 75 degrees without using your calculator, expressing your answer in short form. How will you do that? Using this, we have sine 75 degrees. Sine 75 degrees is something as sine 30 degrees plus 45 degrees. So 30 degrees plus 45 will give us 75. So using the first identity equation, we have sine 30, okay, cos 45 plus sine 45 cos 30. So sine 30 is 1 over 2. Cos 45 is 1 over root 2. Plus sine 45 is 1 over root 2. Cos 30 is root 3 over 2. So when we simplify this, we have 1 over 2 root 2 plus root 3 divided by 2 root 2. So if we simplify this, we have the LCM as 2 root 2. We have 1 plus root 3. So you can simplify further. When we do that, we have root 2 divided by root 2 by rationalizing. We have this as root 2 plus root 6 divided by 4 as the answer. So we have root 2 plus root 6 over 4. So you can solve this for cos 75 degrees. And also you can solve for other related, like when we want to deal with 45 and 60. So when you add 45 and 60, that will give us 105. So you can solve sine 105 degrees. Okay? You can also solve cos 105 degrees using the same concepts and expressing your answer in short form. Okay, that is an interesting part. Okay, we can also look at the tangent of angle. When you talk about double angle tangent, tan A plus B. What is tan A plus B? Tan A plus B is sine A plus B divided by cos A plus B. And what is sine A plus B? Sine A plus B is sine A cos B plus sine B cos A divided by cos A plus B. We have cos A cos B, subtract sine A sine B. But we can't leave the expression in that form. We have to simplify further. So for us to do that, we divide the expressions, the entire expression, by cos A cos B. So when we divide the entire expression, divide by cos A cos B. Let's see what it will give. So we have tan A plus B is equal to sine A cos B divided by cos A cos B plus sine B cos A divided by cos A cos B, all divided by cos A cos B divided by cos A cos B minus sine A sine B divided by cos A cos B. So we simplify this expression. So when we simplify this expression, what are we going to arrive at? Look at it very well. We have this, we cancel this. And this, we cancel this. Okay, this, we cancel this. This, we cancel this. And also, in this case, sine A and this, they are, we can take them together. Recall that tan theta is sine theta over cos theta. So we apply it in solving that. Sine A over this will give us tan A. So we have tan A for this. Okay, that's tan A plus sine B cos B will give us tan B. So we have tan B divided by, what we have here is 1. So everything is cancelled out. 1 minus sine A over cos A is tan A. That's tan A. Sine B over cos B is tan B. So at the end, we have tan A plus tan B is equal to tan A plus tan B divided by 1 minus tan A tan B. So with that, you can solve for tan A minus B. You can deal with this. Okay, when you deal with it, you'll be able to see that this will give us tan A minus tan B, all divided by 1 plus tan A tan B. So you can do this at home and see how the relation, using the same concept, you'll be able to arrive at an answer. Okay, so let's solve a question using that approach. We have tan 75 degrees. Tan 75 degrees, we have it as tan 30 degrees plus 45 degrees. So if you want to solve tan 30 degrees plus 45 degrees, what you have is using the equation that is just established, okay? So we go back and say, okay, let's see how we solve that. We have tan 30 degrees, okay, plus tan 45 degrees divided by 1 minus tan 30 degrees tan 45 degrees. So tan 30 is 1 over root 3, and tan 45 is 1. All divided by 1 minus tan 30 again, 1 over root 3, multiplied by 1, because tan 45 is 1. So when we simplify this further, we have 1 over root 3 plus 1, all divided by 1 minus 1 over root 3. So we can rearrange this and say we have 1 plus root 3 over root 3 divided by root 3 minus 1 over root 3. Okay? So with this and this will disappear. And we have root 3 plus 1 over root 3 minus 1. But you cannot leave the answer in that form. It is a vulgar equation. So what you do here is to simplify further. So we have root 3 minus 1 over root 3 minus 1. So when we simplify this further, we have this as root 3 all squared, is difference of 2 squared, minus 1 squared, all divided by this one, you can say, multiply this. We have root 3. Okay? So we have root 3. Are we doing, okay, from this? Okay, sorry for that. We quickly use the other techniques. solve using this approach. Let's apply the other, do it the other way around. So if we have to do it the other way around, the answer will come through the other means. So if that is done, we have root 3 plus 1 over root 3 minus 1. What you do is you change this to plus. So we have times root 3 plus 1 over root 3 plus 1, because that is the conjugate of the denominator. So that will give us, since this is plus, you multiply root 3 will give us 3. Root 3 times 1 is root 3. 1 times root 3 is root 3. 1 times 1 is 1, divided by root 3 multiplied by root 3 is, that is 3. Okay, this is the difference of 2 squares. All squared minus 1 squared. So finally, we are arriving at the final answer. 3 plus 1 is 4. Add root 3 plus root 3, 2 root 3, divided by 3 minus 1. Okay, so finally, we have 4 plus 2 root 3 divided by 2. So can we leave the answer that way? Okay, no, because we still have something out there. So tan 75 degrees is 2 in bracket, 2 plus root 3, all divided by 2. So 2 cancel 2. So final answer, we have 2 plus root 3 as the final answer. Okay? So that is the answer for tan 75 degrees in short form. That is the answer in short form. So when we apply these trig ratios, we can solve some complex trig functions. As we move ahead, we are going to see some others again. So we have other expressions that we can attempt and solve. Attempt those ones. Before we move on to graphs of trig functions. Graphs of trig functions. How do you deal with graphs of trig functions? When we come across graphs in trig, we talk about, for example, y equal to sine theta, or y equal to cos theta, or y equal to tan theta. Basically, these are the three we need to understand before we understand others. And let's say we are dealing with from 0 to theta to 360 degrees. We need to have an interval for us to deal with this. First of all, we'll prepare a table that will accommodate the range. So if you want to get a table that will accommodate the range, we have theta, okay, from maybe let's use the interval. The interval we are considering here, interval of 30 degrees. If you consider interval 30, we have 0, we have 30, we have 60, we have 90, we have 120, we have 150, then we have 180, we have 210, we have 240, then we have 270, then and so on and so forth. We have 300, 330, and 360, okay, and 360. So let's see, we are looking for sine theta. How do you get sine theta? Sine 0 is 0. Sine 30 is 0.5. Sine 60 is 0.866, okay, or 87. 87 approximately. Sine 90 is 1. So you can say 1.0. Sine 120 is the second quadrant, and that is 0.87 again, the same angle. Sine 150 is the same thing as sine 30, that is 0.5. Sine 180 is 0. It returns you back to 0. Sine 210 is in the third quadrant, so it will give us the same value as sine 30. Okay, sorry, sine 30, okay, because we subtract 180 from there, but in a negative way. So we have minus 0.5. Minus 0.5. Sine 240 will give us minus 0.87. You can confirm that with the calculator. And sine 270 will return us back to the 1. Or we have sine 90. And that will be negative, minus 1.0. Sine 300. Sine 300 will take us back to sine 30. That is equivalent. But in a negative quadrant, it will be minus 0.5. Okay? Sine 330 is equivalent to sine. Okay, this one will give us sine. This one will give us negative 0.8. 0.87, and this one is negative 0.5. Then 360 will return us back to 0. 360 will return us back to 0. So y, we have the same value. So if you are sketching the graph for this, we want to sketch the graph of y against sine theta, against theta. We are drawing this kind of curve. Okay? The graph of this will give us something like this, of this nature. Okay? We start from 0. We have, at this point, it attains 90. And at this point, we have 180. And here, it will give us 270. Then here, 360. Okay, so that is it. It continues like that. But this other side can be off from it. Can be off. Okay, this side is off. Can have it off from there. So it's not part of it. So we have this y as a function of theta. When we draw the graph of y as a function of theta, we have this kind of curve. But when we draw the graph of y as a function of theta in terms of cosine, okay? When we draw cos theta, here we have, starting from the origin, it goes this way, like a cup or plate shape, or kind of a plate shape. But you can also have it in this form. Okay, this is furthermore, so we may not have the detail here. Okay, but in your mathematics class, you'll be able to do a lot of graphs that relate to this. So this is a cosine function. You can start from negative. Okay, but we can have a more complex function where you have y equal to sine x plus cos x, and you are asked to plot the graph. When you are asked to plot the graph of this from 0 to x and x to maybe 210 degrees, the first thing you do is to draw your graph, your table, get your table drawn out. We have x. The first value using interval of 30. Let's use interval of 30. Okay, we have 0. 0, 30 degrees. We have 60, 90. The values of x from 0 to 210. We have 0, 30, 60, 90, 120, 150, 180 degrees, and 210. Okay, so what is sine x of 0? Sine 0 is 0. Sine 30 is 0.5. You can make it 2 decimal. Sine 60 is 0.87 approximately. Sine 90 is 1.0. Sine 120 is 0.87. Sine 150 is 0.5 again. Sine 180 is 0. Sine 210 is in the third quadrant. So when we do the distance, we have minus 0.5. Okay, that is for sine 210. So we do for cos. Cos 0 is 1. Cos 0 is 1. Cos 30 is 0.87. Cos 60 is 0.5. Okay, cos 90 is 0. Cos 120 is in the second quadrant, so it will give us negative value. And the negative is same thing as this, so that will be minus 0.50. Cos 150 is also in the second quadrant. That is cos 130, that will be minus 0.87. And cos 180 returns you back to 0, that is cos, that will be minus 1.0. And cos 210, that will be third quadrant, that will be negative again, but returns you back to this, that will be minus 0.87. Okay, so we can easily add the two functions, sine and cosine. We have 1. Add this together, we have 7. We have 2. Okay, we have 3, not 2. We have 3. Okay, point. We have 1.37. And here we have 7. We have 3. We have 1. Okay, here we have 1.00. Here we have, you have to subtract this. We have 7. Okay, this one will give us 3. That will be 3. Then, since it's a negative, so we have 0. Since it's subtraction, so we have this. This will give us negative again. That is 7 minus this will give us, that will be minus 7. We have 3, 0. So here we have, okay, we have minus 1.0. And here we have, add this together, we have 2. Okay, let's, we have to, this is 0.0, okay? Okay, that is a 0.0. So that will give, this one is still 0.0. So we add this, we have 7, we have 3, and here we have 1 with your negative. So we have this as a table for this function, y equal to sine x. So when we sketch or draw the graph, let me just do a sketch here. We have y, against that 0, we have 30, we have 60, we have 90, we have 120, we have 150, we have 180, we have 210. So when we have this, the maximum value there, we can take this as 1 and take this as 1.5. Same here, 1, this is negative, and all that. So by the time we draw the graph of this, doing a sketch of this, we have 0 to 1. 0 to 1, that will be around here, okay? That will be around there. And 30 to 1.37, 30 to 1.37. So 1.37, 60 to 1.37 again, so it's repeated, 90 to 1. So it comes back to this point, 120 to 0.37, so it goes down. It goes down to somewhere around there. Then 150 to minus 0.37, so it goes negative sign, goes to the negative. 180 to minus 1 point, that, so we have something around there. And 210 to minus 1.37. So it comes down further to something. So when you draw the graph, we have something like this. Okay? So it goes down and like this. And if it continues, we may arrive at a point and see it going back to the top value. So with that, you can solve problems related to that. You can add this as part of your function. Y equal to sine 2x. You can draw the graphs of all this as your practice work. Y equal to sine x minus cos 2x. Okay? And the third one is y equal to 2 sine x plus 3 cos x. Okay, using the angle 0 less than x, x less than 360 degrees. Okay? And you can use interval. Use the interval 30. Interval 30 degrees to prepare your table. So with that, you can solve some problems in trig functions. Okay, with that, let's look at others. There are related terms and curves in trig identities and trig functions. And in summary, we have been able to understand that the trigonometry have to deal with a whole lot of measurements, and we should be using it to solve a lot of problems, even in other aspects of trig or further mathematics, such as calculus and the likes, and physics. So that will help us in other areas. And others, we can also add some simple terms. Recall this. Recall that sine x is equal to cos 90 minus x. So you can solve a simple problem. And also cos x equal to sine 90 minus x. So that means sine 60 degrees is equal to cos 90 minus 60. Okay? Cos 90 minus 60 is cos 30. So with this, you can solve some problems like cos 2x is equal to sine 40 degrees. Okay? Find x. Find x, or solve for x. And cos 3x plus 8 is equal to sine x minus 10. Find x in both cases. So you can apply this and solve this problem. Then others can lead to simultaneous equation and the like. So we appreciate those of us that have listened to this class, and I believe that in subsequent classes you will be able to apply it in other areas as we wait for further class. So thank you for listening, and have a great day.